Now, what do we want to find the area to the right of a number? Like I said, in the with a table, you would have to do area to the right is 1 minus the area to the left. And there's no way around this because your table only gives you area to the left. But the truth is, with the calculator, you don't have to do this, right? With the calculator, all you have to do is put, change this. I can do second distribution, normal CDF. And I can put here from the 0.25 to the 0.75. And I'm finding the area between 0.25 and 0.75 under a normal curve that has mean 0 and standard deviation 1. Okay, so you don't have to go left to 75, left of the 25, and subtract them. So if you read the book, it's going to do this. It's also going to, in the homework, it might tell you what the values are, and you know you need to subtract them. But know that you can do this if you're not required to do the 2 steps. Okay. Now, I was talking about this. It's very easy in 5.2 and say, oh, now what's the difference between 5.1 and 5.2? In 5.2, we are going to find areas to the left or right or between two numbers of means, standard deviations of normal curves that have means different than 1 and standard deviation. Sorry, means different than 0 and standard deviation different than 1. So my first example is IQ scores follow a normal distribution with a mean 102 and standard deviation 13. What is the proportion of individuals with an IQ score of 95 or less? So one way to do this, and this is the logic that I want you to understand, although we don't have to do it this way, I need you guys to understand what's going on, how to do this method. Okay, the first method I'm going to do up here. So what I can do is find the z-score, right? So the z-score of 95, so you do 95 minus 102 divided by the standard deviation, it gets you negative 5.4. This means you're 0.54 standard deviations away from the mean, right, to the left of the mean. So if you want to find now the area under the standard number curve, all you have to do is find the area to the left of negative 0.54 under the standard number curve. Okay, and you get this, and you type it in, and you get 0.295. Okay, again, in my command here, I did not include the 0 and the 1, because if you don't put them here, it assumes you're using mean 0 and standard deviation 1. So that means that 29.5% of those individuals who take the IQ test get 95 points on this. Okay, now, if it's a calculator, you don't have to do that, right? All you have to do is type this. Your calculator can have you a small number, an x value, and you write a mean and a standard deviation, so you can just directly write these numbers, right? Negative 1,000, x, 102, 13. Sorry, I didn't put the x. What is the x? The x would be 95, right? So let me do it over here in my calculator window. I would do second distribution. Let me create a window. So second distributions, number 2, negative number. I don't care how big it is. Yeah, let's do that. I want a 95, all the way to 95, and do a mean that has, on the number curve has means 102, and standard deviation is 13. So you don't have to convert to z-scores to solve the problem, because your calculator does it. And again, if you don't have a menu, if your calculator does not prompt you for that menu, you have to type it here in this command line. Just know the order. It's left, right, mean, standard deviation. Okay, you press that, press enter, and you get the same answer. Okay, so you don't need to convert to z-scores. Now, some problems in the book for the online homework might ask you to do it because that's what it does. So be sure that you know how to do this method up here. Okay, but in a shortcut, you can always do this. Now, I want to warn you, you don't have to do it both ways. Some students get used to doing it both ways to be sure they're doing it right. And the problem with doing that is that then in your exam or quiz, one of the two ways is wrong, and then you spend too much time trying to find it, and well, then you don't have time to finish the quiz, right? So be sure that you know one way, and that's it. Or people get confused by doing one way than the other. So you need to know how to do both, but please, in an exam or a quiz, just do one. Be sure you know how to do it and do it fast. You're not going to spend too much time doing this. Okay, example. Each month, an American household generates an average 28 pounds of newspaper for garbage of recycling. Assuming standard deviation is 2 pounds, If the health score is set at random, what's the probability that it's generating between 27 and 31 pounds per month? So what do? This is Normalcdf. It's very simple. Once you identify what kind of problem it is, you do Normalcdf. You want to find the area under a normal curve. It has a mean 28 and standard deviation 2 between 27 and 31. And that's what you do. I type it in here. If you do the numbers, let me check if you want. I find, let me clear, second, Viral's Normalcdf, so I can scroll down or press number 2. The lower number is 27. The upper is 31. Under a normal curve that has mean 28 and standard deviation 2. Okay, 62%, 60.4%. How about more than 32.2 pounds per month? Well, it's the same thing. Now you want to do to the right of 30.2, so you type 30.2 for your left, a big number for your right bound, and the same mean and same standard deviation. Okay? Okay? So let me stop this video here, and I'll have one more example, sorry. American Automobile Association reports that the average time it takes to respond to an emergency call is 25 minutes. Assume the variable is approximately normal. The standard deviation is 4.5. If 80 calls are randomly selected, how many will be responded in less than 20 minutes? Sorry, less than 15 minutes. In less than 15 minutes, so again, identify it's a normal curve, mean is 25, standard deviation is 4.5. And we're trying to find the error to the left of 15. So I put a negative number up to 15. Under normal curve has a mean 25 and standard deviation 4.5. So I get this very small area. Now this is not the question. The question says how many calls if there were 80. So it's 1.3% of the calls. So I have to multiply that times the 80, right? Which is basically about 1 call. Okay. Okay. So this is 5.2. So be sure you get this, and I'll make a video for 5.3 in a minute.